so you don't have to memorize them. This is 3.6. Okay, so basically you just need a function and you need a point A, and then as long as x is near A, it will give you a good approximation for your function f of x. So the examples that we did dealt with like square root function. That was the most common example I think that we did. For example, this one right here, okay? It says find delta y and f prime of x delta x for the given function. It says round to 5 decimal places. So here we have y equals f of x. It's the square root function, square root of x. X equals 3. And the change in x is equal to 0.07. Now, this is a little bit confusing because they say x equals a, but what they really mean is your a, that's your fixed value. So that a is actually equal to 3 in our formula. So these problems can be a little confusing. So I just want you to make a star in your notes to remind you that a is equal to 3 for our formula. X is near a. So this x, when they say x equals a, they mean a fixed value for x. This is the variable right here. So this is near a equal to 3. All right. Now going back to the problem, I forget what the question asked specifically, so let me just take a look at that. They want us to find delta y, and they also want you to find f prime of x delta x. Okay, so I suppose for this particular problem, their x, this x here is the x that they want. And so so see this piece where it says f prime of x delta x? That corresponds to this piece right here. So I should probably change the way I teach this in the future. I've always used this formula, but the textbook, so this piece right here, okay, corresponds to in my formula, f prime of a, x minus a, okay? And the reason why I've always used this formula is because the x is used typically as a variable, and I like to take a constant like a to show that I'm talking about a fixed value, 3 in this case. And they're saying x equals 3, but then over here, your x is a variable. So it's kind of confusing. They're doing double duty here for x. So I've always used this formula here. So I might have to rethink that if I'm teaching out of this particular textbook. But I want to call your attention to that to, hopefully I'm not confusing you even more, but we're just using a different label, okay? I like to reserve x as a variable. They're treating it, they're giving double duty to x. Here it's a variable, here it's a constant. So I'm a little bit more, anyway. But this is the piece that they are wanting us to calculate. And the change in y is the actual change, okay? So the change in y is going to be your value at the two x values, okay? So here we have 3, and then we have the change in x is 0.07. So it's going to be f of 3.07 minus f of 3. This is the actual change in y, okay? And because it's the square root, you're going to be taking the square root of 3.07 minus the square root of 3. And you're going to need your calculator for that. I think I'm going to go over here and use this screen. So the change in y is 0.02. And if we go to our homework, you can see there's some choices here. They go out to 5 decimal places, and so I better double check and see what my calculator says here. 0.02009 is the change in y. So, and it's good since you have a multiple choice test, you know, you can eliminate A, okay? So now we just have to check the second piece, which is the f prime of x delta x. And so here we're going to x equals 3, so we're going to plug that into our derivative. So we need to calculate the derivative. And think of this f of x here as x to the 1/2. So when you take the derivative, the 1/2 comes out front because I'm applying the power rule, because we have x to the power of 1/2. 1/2 times x, and then I subtract 1, that's going to give me negative 1/2. Which can be then written as 1/2 square root of x. So I'm going to take my x value equal to 3 and plug that in here. And then I'm going to multiply by the change in x, which is given to us as 0.07. So going back to my calculator, we have 1 divided by 2 divided by the square root of 3, and then multiplied by 0.07. We have 0.02021, because if we round this to 5 decimal places, it's going to be 0.02021. Whoops, I wanted to go to the other screen here just a second. There we go. So it looks like B is the correct choice. All right. So if you run into this problem on the test, which there'll probably be one problem similar to this, you're going to want to maybe not use my formula, just stick with what they're asking you for. So you're going to take f of 3 and subtract it from f of 3.07, because your x value, or when you have the change in x, that means your x value, your new x value, right? This is the fixed x value, and then you have a new x value is going to be 3.07 when you add this change to it. And the change is positive, so you're going to take the larger value and subtract the smaller value, and then calculate your change in y. And then you just plug in this x you find the derivative, plug in 3, and then plug in this value for delta x. And then you have both answers there, okay? I'm not sure yet if there's a problem like this on the test. I have made up the test, so I'm not sure. There may be one similar to that. This is the same basic procedure. Same thing here. Okay, so here we have find the linearization of L of x, and now look at how they're switching it, x equals 3. So this is using the formula that I am familiar with, okay? Really, it's the same thing, but here they use a previous problem. Maybe I'll just stick with one like this, and just to avoid the confusion when I take a look at the test. And this is number 43 on your review. And I'm going to, our function f of x equals x squared. And then it says you've got parts A, B, C, and D, and then you make the correct choice, okay? So A equals 3. And you want to use the linearization to approximate 2.9 squared. So you want to approximate, I'm writing this all down so I can do the problem for you, 2.9 squared. And then you want to use your calculator, and then what is the difference between the approximation and the actual value? Okay, so that's A, B, C, and D. All right, so the first formula that we're going to use is f of x equals f of a plus f prime of a times x minus a. And compared to the previous problem, this is the change in x. All right, and this is and our a value is 3. Okay, so I think there are going to be 30 questions on the test. That's my plan. It's going to be, the test is going to be, let me think. A regular classroom is 75 minutes. So I'm going to allow 75 minutes. So if you happen to be in the group taking the final exam during the regular scheduled final exam date, you're going to be allowed 75 minutes because I want it to be fair across all my sections because I'm curving the test based on all my sections. So you're gonna have 75 minutes. Even though the exam period is 2 hours, I'm gonna limit you to 75 minutes because it's a 75-minute test, okay? So, and it'll be very similar to the midterm. All right, going back to the problem, I just want to check and see what A says. So the first thing is to find the linearization L of x of f at a equal 3. And I probably should be careful how I write this. I put f of x equal to, and I just honestly meant when I wrote that is approximately equal to, because this is your L of x. Okay, so I should probably have been more careful about that. L of x is equal to this formula here, and it's approximately equal to f of x, okay? So this is called the linearization, right? This is the slope, right? The derivative is the slope of the tangent line. So you're taking the tangent line and you're approximating your function using the tangent line, and this is the equation of the tangent line. Here's the slope. And you multiply by x minus a and add f of a, and that will give you an equation for it. And the tangent line is at a. So there are many tangent lines for a function, but at A, it's equal to this. And that's why that's why we use the letter L, because it's the linearization. F of X is approximately equal to that. So I apologize, earlier I wrote it up here, and you might want to fix your notes and make sure that you understand approximately. That's what that wavy equal sign means. It means approximately. Okay, so going back to this, you just want to find this equation. So the first step is to take the derivative. Our function is x squared, the derivative is 2x. So f prime of A is f prime of 3, and that's 2 times 3, which is 6. All right, so this piece is 6. F of A is equal to 3 plugged in here, 3 squared, which is 9. So we have 9 plus 6 times x minus 3. And you want to go ahead and distribute the 6. Okay. And 9 minus 18 is negative 9, so this becomes 6x minus 9. Now, let's go ahead and go back to the problem, and we can eliminate some choices here, okay? And just to save yourself time, and also to be, so maybe you don't even have to go through all of this, check, and we've eliminated now B and C because we see the linearization is 6x minus 9. Okay, so part A is done. Now B says use the linearization to approximate 2.9. And so you can see we have two numbers here. It's either 8.41 or 8.4. And once we make that determination, we can select the correct choice. So you don't even have to do all the rest of this stuff. We just need to determine, is it 8.41 or is it 8.4? Okay. So now it says use the linearization. That means they want you to use this function to approximate 2.9. And that's the whole purpose of the linear function, is to approximate the actual function. That's what we're doing here. We're finding the approximation. So L of 2.9, is that what it was? Just let me double check to make sure. I think it said 2.9. Yes, 2.9. Okay, so L of 2.9 equals, and this is the formula for L, 6x minus 9. So 6 times 2.9 minus 9, and I'm going to go back to my calculator. And we have 6 times 2.9 minus 9, 8.4. So, whoops, going back to the homework, we see that it's exactly 8.4. So A is the correct choice. And I didn't even have to do part C and D because I've eliminated the other three choices. Okay, whoops, did something wrong. Oh, I clicked the wrong one. I saw this 8.4 here. And I was, that's the answer to part C. Here it is, 8.4 is D. There we go. Okay. I guess you have to be really careful on those, that you're answering the right question. I was looking at C and I got the answer to C, so be careful. All right, so this is the same situation. The only difference here is we have a different function. And this is pretty easy though, because the derivative of the e to the x is equal to e to the x. Okay, so make sure you know your derivative rules for these. All right, this is another really good problem that I like these type of problems because they're application to business, which You all are business students, so I like those type of problems where I can at least show you how this stuff is used. So make sure you practice these problems and know what they're asking you. So we have the weekly profit in dollars from the production and sale of X bicycles is given by P of X equal 90X minus 0.005X squared. Currently, the company produces and sells 600 bicycles per week. Use the marginal profit to estimate the change in profit if the company produces and sells one more bicycle per week. So the thing about this is you have to translate all of this information into your linearization. And you have to recognize, first off, that when you see a question like this on the test, that you know what kind of problem it is, okay? That's probably the hardest part. So I'm almost positive, I am sure there is a problem like this on the test. So make sure that you first can identify what it's asking you. And here's some keywords. You've got one more bicycle per week. That is showing you, here you have a number for bicycles, 600 bicycles. And then the keyword here, estimate. What is your profit if you sell one more bicycle per week? You're estimating, that's keyword there is linearization, and the one more bicycle per week means you're changing your X. You're going from 600 to 601. You see that? One more means you go from 600 to 601. There's a change in X. So all of this, for people who know about linearization, it screams at you, linearization. And that's what you have to, when you're taking a test, you don't want to waste time reading something and going, what in the world are they asking? You need to be prepared and know there are going to be questions like this that are asking you to apply the linearization. So let me write down, this is number 45. Let's see, I'm going to write this stuff down and then I'll show you how to do it. P of X is equal to 90X minus 0.005 X squared. And we have our A value is 600 and our change in X value, or the X minus A, is 1. Okay, and then we got to find out what is the change. Okay, this is a tricky problem. Notice it says change in profit. So they're not asking you to estimate the profit, they're asking you to estimate the change in profit. So let me show you our function. Okay, our function is P of X. So we want to use P of X, and what this is saying is P of X is approximately equal to L of X, which is equal to your P of A plus P prime of A times X minus A. Okay, so that means P of X is approximately equal to, what's P of A? Well, P of A is taking your 600, I'm just going to plug this in here. Okay. So P of 600 going back to the calculator. Now you don't need to use P of 600, but I'm just going to write this all out for you so that you can understand what I'm doing here. So 90 times 600 minus 0.005 times 600 squared. So it's 52,200. All right. Now we have to calculate the derivative, right? And evaluate it at 600. So P prime is going to be 90 minus 0.01x. If I take 0.005 and multiply it by 2, I'm applying the power rule here, I get 0.01. And then, of course, I have to subtract 1 from the exponent, so I just get x here. And now, to evaluate this, P prime at 600, if I take 1/100th of 600, that's 6. 90 minus 6 is 84, okay? So I'm going to be using these two pieces of information, okay? So I get $52,200 plus 84 times, what are we approximating here? We're approximating the profit when you have one more bicycle. So this piece right here, in other words, we're looking at P of 601. All right. So here's the profit at 600. Then you have a change in the profit, and that's the derivative times the change in X. Well, the change in X is just 1, right? Because it's 601 minus 600. So this is 1. And so then we have $84 times 1 is just 84. All right, so what does this mean? This is the profit at 600. And this is the change in profit at 601. Okay, see that? So the problem could ask you, what is the approximate the profit? If you're asked to approximate the profit, then you want this sum. You want to take 52,200 plus 84. If you want to approximate the change in profit, then you give this number 84. See that? So these things can be tricky. There's a lot of information in this problem working, and you need to recognize what it's asking you. But it helps that this is multiple choice, because when it's multiple choice, you can check. Oh wait, my answer is not there. If you had added the two numbers together, you would have recognized, oh, I put the wrong one. So 84 is the change in the profit.
Can you show how to add 84 again for the equation?
This is the linearization. This linearization approximates the total profit at 601. This is the profit at 600 plus the change in the profit. So if they want you to approximate the profit at 601, you would add them together and that would be your answer. But for this problem, they just wanted the change. So those little details, you just got to be real careful. Right here, it says change in profit as opposed to profit. If this had been taken out, then it would have been a different answer, obviously. So just some things, pay attention to this because there is a problem like this on the test, okay? And there definitely will be. All right. The total cost in dollars to produce so many DVDs is C of X. Find the marginal cost when X equals 8. This is an important thing. It's a real easy thing to know. Marginal just means derivative of, okay? So when they say marginal profit, they mean derivative of the profit. If they say marginal cost, they mean derivative of the cost. So this is actually a very easy problem. You're going to take C of X, which is 100 plus 8x minus x squared plus 7x cubed. You're going to take the derivative of that and evaluate it when x equals 8. Of course, taking the derivative of 100 gives us 0. The derivative of 8x is 8. The derivative of negative x squared is minus 2x. And here we have 3 times 7. That's going to be 21x squared. And then I'm just going to take the 8 and plug it in. Let me just do a calculator because my brain doesn't feel like doing that this morning. Okay, it's too early. All right, so we have 8 minus the 16 and then plus 21 times 8 squared. So 1336. And let's see. There we have it. Okay, any questions so far? Anything you want to? I don't know why I did that. Going back here. There we go. That's better. Same thing. Marginal profit. Take the derivative, plug in 2, find out your answer there. That's pretty simple. Here's another one of those linearization problems. How do I know this is a linearization problem? Well, I've got 60 units and then I'm changing it to 63, okay? So my change in x is 3. I'm going from 60 to 63, change in x is 3. So that's a key word. Here is another keyword, estimate, marginal. When you see the word marginal, you know you're going to take the derivative. When you see the estimate, you're going to use the derivative to estimate something. That's the linearization. So that's how I know that's the type of problem I have here. Okay, so I know for a fact there's something like this on the test where you have to use the linearization. So I'll do another problem. We have our function. This is, by the way, number 48. We have our function c of x equal to 0.001x cubed plus 0.3x squared plus 73x plus 600. All right, and a equals 60. And the change in x is going to be 3 because we're going from 60 to 63. Now, what is it asking us? Estimate the daily cost. So the previous problem we did, it said estimate the change in that case it was profit. But here they're actually asking estimate the daily cost. So we are going to be adding those two numbers together. First step is to calculate the derivative. Then you're going to evaluate your function at 60. All right, so we plug in 60 into our original function, and we're also going to evaluate the derivative at 60. So the derivative is going to be 0.003 60 squared plus 0.6 times 60 plus 73. So you find the derivative, then you evaluate both the original function and the cost function and the marginal cost at your 60, which is your A value. And now that you've got all that information, let's go ahead and calculate those numbers to see what we get. So we get 6276. And then for, let me make sure I did that correctly. It looks good. 0.3, yeah. Okay. And then for the derivative, we're going to get 0.003 times 60 squared plus 0.6 times 60 plus 73. And we get 119.8. Okay. So at this point that we have our information, we can then use the daily cost is approximately equal to the L of X, which is C of A plus C prime of A times X minus A. C of A, and this is just evaluated at, so we're looking at, we want to know the cost at 63 units. That's going to be approximately equal to L of 63, which is C of A, that's C of 60, remember A is 60, plus C prime of 60 times 63 minus 60. This is the change in X. That's 3, right? The change in X equals 3. That's this piece right here. So this becomes 6276. So that's the cost at 60. Then we're going to add the change in the cost, and that's going to be the derivative, which is 119.8 times 3. So this is what we're calculating. So 6,635.40. Be careful here. Notice I have two choices that are very close. So the 40 cents means I'm going to round it down. All right. All right, now moving on to section 3.7. So again, you're going to be able to, you're going to have the formula for elasticity. You don't have to worry about memorizing that. You just have to know how to use it. So the elasticity is a function, and we use the demand function to calculate the elasticity. So E of X equals minus X times the derivative of the demand function, or the marginal demand, divided by your demand function. And like I said, this is the formula I will give you on the test. So in this particular problem, we're given that d of x equals 700 minus 4x. So d of x is negative 4. And then we just plug this into our formula. The double negative means I have 4x over 700 minus 4x. And it may or may not be in that form, but going back, you've got your multiple choice here to select the correct one. And we can see that, let's see here. It looks like they reduced it. That's what it looks like to me. So I don't have it in the correct format. Now be careful, because look here, my first impulse was to select this one because I saw the 700 minus 4x in the denominator, and mine has a 4 in the numerator, so I know that's not the correct one. So I'm going to go back and then simplify this. How do I simplify this? Well, notice that 4 is, I can take out a 4 here, here, and here. The only way you can do that is if you can do it for every single factor or every single term in your problem. So because I'm going to multiply the numerator and the denominator by 1/4. So I have 1/4 in the numerator and then 1/4 in the denominator. And I need to distribute that 1/4 in the denominator. So this is going to become x over 1/4 times negative 4 is, of course, negative 1. So I know I'm going to have minus x here. And if I divide this by 4, I get 4 into 7, and then 300 divided by, so it's going to be 175. Okay, now going back to the choices, I can see I have x over 175 minus x. So D is the correct choice. So don't rush through and be tempted to settle like, oh, I'm off by a constant. This is probably the answer. You're going to get it wrong. And so, even though you have the formula, even though it looks pretty easy to do, don't be careless, and that it'll cause you to lose points. So some advice there. All right, let's do one more example for the elasticity, and then we'll talk about maximizing revenue. This time our function is d of x equals 900 over x. Okay. So the first step is to calculate the derivative. Now, when you see a function like this, you should be able to recognize that as a power function. In other words, this is 900x to the negative 1. The negative 1 means that your x is in the denominator. Okay. So, but this is the preferred form because then it's easy to find the derivative by applying the power rule. Negative 1 times 900 is negative 900. And then I subtract 1 from negative 1, it's going to be negative 2. And simplifying this, it becomes negative 900 over x squared, like that. Now I can plug this into the formula. It's minus x times negative 900 over x squared divided by 900 over x. And when you divide by a fraction, you multiply by the reciprocal. So this is going to be, first off, the double negatives will be positive. And so this is going to be x times 900 over x squared times x over 900. And then you can see the 900s cancel. And so this becomes x squared over x squared, which is just 1. And so it has elasticity of 1. When it has elasticity of 1, this is called unit elasticity. All right. So here's some more examples. Again, you want to write this as 500 minus x to the 1/2 power, okay? And then take the derivative using the power rule. Here you would write this as 400 times x plus 8 to the -2, and then use the power rule. Okay, now the question is, for the demand function given, find the elasticity at the given price and state whether the demand is elastic, inelastic, or whether it has unit elasticity. So if your elasticity is less than 1, it's inelastic, and if it's greater than 1, it's elastic. So just, calculate the elasticity, and then you just check. If it's less than 1, it's inelastic. If it's greater than 1, it's elastic. Same sort of thing here. These problems are all very similar. Now, this is important. There will be a problem like this on the test. For the given demand function, find the value or values of x for which the total revenue is a maximum. That just means your elasticity is equal to 1. Okay, that's all it means. But you have to know that, right? It's a very simple problem, but you need to know what that means, okay? If your revenue is a maximum, your elasticity is 1. So here's my demand function, d of x. This is number 56. D of x is equal to 800 minus x. And the derivative of the demand function is negative 1. And so the elasticity is minus x times -1, that's the derivative, over 800 minus x. So the double negative means x over 800 minus x. So this is the elasticity. And because we're looking to see where, right, that's an x value, where the demand function, or where is the revenue a maximum? The revenue is a maximum when your elasticity is equal to 1. Write this in your notes. This is important. Otherwise, you won't know how to do the problem. Revenue is a maximum when elasticity is 1. So we set E of x equal to 1. All right? So you say, I can just hear you saying it. Where'd that 1 come from? Okay. First I calculated the elasticity right here, and then I set it equal to 1 because I want to know when the revenue is a maximum. So all I have to do is solve this. So let me write that too. Alrighty, so x over 800 minus x equals 1. Now, how do I solve that? Well, what screams out at me right there is cross multiply. 1 over 1 is 1, and so I'm going to cross multiply. So I'm going to take x times 1 is equal to 800 minus x times 1. So in other words, x is equal to 800 minus x. This is an easy equation to solve. I just add x to both sides, and I get 2x equals 800. Dividing both sides by 2 gives me x equal 400. So there's my answer. Same sort of problem right here. I know there's a problem like this on the test, so let me do this one for you. Number 58. We have d of x equals the square root of 800 minus x. Again, we're looking for the value of x for which total revenue is a maximum. Whenever you see this, this means calculate e of x and set it equal to 1. So I'm just going to belabor this point. I don't want to say calculate, I'm going to say find e of x, set it equal to 1, solve for x. Those are the 3 steps. Okay? So e of x is equal to, now you want to think of this again, always whenever you see square roots or x's in the denominator, raise it to a power. So this is 800 minus x raised to the 1/2 power. So I want to first find the derivative of this. D prime of x equals 1/2 comes out front, then 800 minus x to the negative 1/2 power, okay? And don't forget this last step. By the chain rule, you have to multiply by the derivative of what's inside. The derivative of 800 minus x is negative 1. Don't forget that, okay? That's the chain rule. So this is going to equal, and I'm kind of running out of space here. So d prime of x is equal to, the negative means it goes in the denominator, the 1/2 means it's a square root. The 2 is already in the denominator, the negative 1 is, we'll just put out front, so, or we can just, yeah, negative 1/2 times, I meant to do a square root there, square root of 800 minus x. The square root is because of the 1/2. The fact that this whole square root is in the denominator is because of this negative. And then the 1/2 puts the 2 in the denominator. And so this is our demand, or a marginal demand, I should say. Minus x times the marginal demand divided by this function here. This is getting kind of messy. I don't want to put one like this on the test. It's just a little too messy. I'll try to keep it simple. Okay, but since we've started it, let's just finish it, okay? So basically I've got minus x times negative 1 is just going to be positive x. That's in the numerator. Then in the denominator, I have the 2 square root of 800 minus x, and then I'm going to multiply by, this thing is in the denominator, so I'm going to multiply by 1 over the square root of 800 minus x. Now we have 2 square roots of the same thing, so that is just going to be x over 2 times 800 minus x, right? Because square root of 2 times square root of 2 is 2, right? Square root of 5 times square root of 5 is 5. So square root of 800 minus x times the square root of 800 minus x is just 800 minus x. See that? And now we can set it equal to 1. Okay? So getting to this point, this is your step 1. And then the fact that you're setting it equal to 1, that is your step 2. And now we just have to solve it. So step 3 is going to solve this equation, and you're going to cross multiply. So we've got over 1. When you cross multiply, you have x times 1, x equals this times 1, which is 2 times 800 minus x. So x equals 1600 minus 2x. Then you're going to add 3x to both sides. So, I'm sorry, not 3x, 2x to both sides, which gives you 3x. I was kind of getting ahead of myself there. 3x equals 1600. So x equals 1600 over 3. So this is where, remember where, when you ask the question where, it's always an x value, right? So this is where the revenue is a maximum. So going back to the problem, C is the correct answer. Okay. Same thing. Which total revenue is maximum? So you have a lot of problems here to practice this. Now we're on to calculating derivatives or anti-derivatives. Okay, there are 2 types of integrals. They're indefinite integrals and definite integrals. Definite integrals are when you have the numbers here ranging, so you're integrating from one point to another point on the x-axis. So you're going to have numbers. When you don't have what we call them indices. When you don't have indices like this, then it's an indefinite integral. So you're going to have the plus c constant unless you're given some initial conditions. So let's just, and there are going to be some easy problems for integration. Now, I want to tell you that you really want to practice your integration techniques because the bulk of the test is going to be integration, since that was kind of the new material that we covered. So make sure you know how to do this. And it's really simple. If you just practice, you'll get really good at it. Okay. So let me do a few examples here. This one is problem 60. We're integrating a simple power function, x to the 6 dx. Okay. So you add 1 to the exponent to get 7, and then you divide out by your new exponent, and then you always add c. It's that simple. You add 1. It's kind of the reverse of the power rule. You're adding, instead of subtracting 1 from the exponent, you're adding 1. And instead of multiplying by your exponent, you're dividing, but you're doing it in reverse order. So normally when we take the derivative, we take 7 and multiply it first, and then subtract 1 from the exponent. Well, we're doing the reverse. We're adding 1 to the exponent and then dividing out. So it's just the reverse of the power rule, okay? But it is the reverse, and so you want to practice, just like when you're driving, you know? It's harder to drive in reverse. So you just got to practice a little bit. So just do that. And they've written, instead of x to the 7th over 7, they've written it as 1/7 times x to the 7th. So you may have to change the format of your answer, but the nice thing is your answer is always there, and you'll never have none of the above as a choice. So if you get the wrong answer, just check and see what mistake you made, or if you have to write it in a different form. Okay, now we have an extra complication here. We have a constant in front. If it helps you, you can move that constant out of the integral if it's multiplied, okay? Not if it's added, but if it's multiplied, you can move it out. So this is 61, the integral of 8x to the 4th dx. All right, so add 1 to the exponent becomes, now the 8, just keep it there. It's not hurting anything. Add 1 to the exponent to get 5 and then divide out by 5. And then don't forget your constant of integration. And so this becomes 8/5 x to the 5th plus c. All right. We have the integral of 4x squared plus 1 dx. And all right, so when you have a sum, you just integrate the terms separately. So I'm going to start with this one. I add 1 to the exponent of 2 to get 4x cubed, and then I divide out by the 3. Just carry your constant along with you. Divide out by your new exponent. Here, I'm going to think of this as, well, a constant. You just take your constant and multiply it by x. So whatever your constant is, to integrate it, you just take 1 times x and then plus c. So this becomes 4/3 x cubed plus x plus c. All right, I'm going to quit there and continue on, let's see, what is it? Thursday. Today's Tuesday, right? Thursday, I'm going to continue. So just go out there, practice. If you, I would suggest going through the review. There are quite a few questions. If you see any that just, you just don't know how to solve them, bring them, bring your questions to class on Thursday and I'll help you with those. All right, any questions before we sign off? All right, thank you very much, and we'll see you on Thursday.